the general solution of y double prime plus 4y equals 8 tangent t. For t between negative pi over 2 and pi over 2, we'll use the method of variation of parameters. This problem is not suitable for undetermined coefficients because the non-homogeneous term 8 tangent t involves a quotient of sine and cosine. We need variation of parameters. First, let's find the homogeneous solution. The homogeneous equation is y double prime plus 4y equals 0. Characteristic equation is r squared plus 4 equals 0, giving us complex roots r equals plus or minus 2i. Therefore, the general homogeneous solution is y sub c of t equals c1 cosine 2t plus c2 sine 2t. In variation of parameters, we replace the constants c1 and c2 with functions u1 of t and u2 of t. We assume a solution of the form y equals u1 of t times cosine 2t plus u2 of t times sine 2t. Now we compute the first derivative of y using the product rule. To simplify, we impose the condition that u1 prime times cosine 2t plus u2 prime times sine 2t equals 0. With this condition, the first derivative simplifies to y prime equals negative 2u1 sine 2t plus 2u2 cosine 2t. Now we compute the second derivative of y. We substitute y and y double prime into the original differential equation. After substitution and simplification, we get negative 2u1 prime sine 2t plus 2u2 prime cosine 2t equals 8 tangent t. We now have a system of two equations for u1 prime and u2 prime. Let's solve this system of equations for u1 prime and u2 prime. First, we solve for u1 prime and simplify using trigonometric identities. Next, we solve for u2 prime and simplify. Now we integrate u1 prime to find u1 of t. Similarly, we integrate u2 prime to find u2 of t. We substitute u1 and u2 back into our assumed solution to get the particular solution. Finally, we combine the particular solution with the homogeneous solution to get the general solution. Let's simplify the final expression using trigonometric identities.